Hello and welcome to Lab 1 for Physics 2 with charge tape. For the fundamental equations that we'll need in order to get everything else, we are taking Coulomb's classic equation as well as the gravitational force equation and combining those with the principles of physics principles of gravity, charge, and the electric fields, as well as using some of Newton's laws, particularly equal and opposite reaction. We are going to analyze the properties of charged tape. Part of the analysis included the use of a GlowScript computer model, but in order to model it with any reasonable time, we had to make a few simplifying assumptions. And part of that is that the model uses point charges and is not a strip of tape, unlike the real world. And it also neglects many of the physical properties of tape, such as its stiffness or any air currents that may have affected the final observed result. And another thing that may have affected it for an error source is that the measurement was performed by ruler and at a slight distance for a reason that we will get into later. For the observed values, they're right here. We had a tape length of 0.245 meters, which was slightly longer than the 20 centimeters, but it was to enable us to have enough room to work with it without getting too close to the center. And the final displacement distance was 5 centimeters. Now, in order to calculate everything from the rest of it, we took the gravitational force on the top tape, which would have been the length of the tape multiplied by the gravitational constant, and got 0.0024 newtons. And in order to calculate the electric force on the tape, we simply used Newton's second law in order to determine that the two forces were at equilibrium, and so that the electric force was equal to the gravitational force at 0.0024 newtons. And after this, we took the computations in GlowScript, and we're able to see that the two forces are equal and opposite, and we're able to also calculate many other details later. Some of that, including in that, was the magnitude of charge on the tape, which was 2.58 e to the negative 8 coulombs. And part of how we're able to calculate that charge was by treating the two tapes as having equal charge, because they were approximately the same length and created through the same method. But that may not have affected reality, may not have reflected reality. And kind of more as a fun aspect, we also calculated the number of electrons that each piece of tape gained in order to get their charge, and in order to get that magnitude of charge. And we were able to determine that relatively simply through just taking the charge and dividing it by the charge of each proton, which would indicate the number of electrons displaced, essentially. And then, to find the ratio of atoms to extra electrons, we simply took the size of the tape and divided it by the size of an atom, squared, because we're dealing with square distance here, and then divided it by the number of electrons, where we got 1 to 3 e to the 6th, which would be 1 to 300,000. So there's one extra electron for every 300,000 atoms that are already on the tape. And for the model, as I already said, the tapes are treated as point charges, and the initial conditions treat gravity and electric force as being in equilibrium. And only the top tape is treated as the system, with everything else being part of the surroundings. Now, what if electrons and protons switched charges? In reality, nothing would happen. Everything we observe would look exactly the same, because it would be equivalent to multiplying by -1 twice. All the protons would have negative charges, and all the electrons would have positive charges, but since opposite charges still repel, then the tape pieces would still repel, and all the positively charged and negatively charged items would still attract. So nothing would actually look different. And the reason that we made sure to handle the tapes as little as possible, especially during the observation phase, is that the electrons want to discharge into the surroundings, in order to become electrically neutral. And so if we handle to them, then we become neutral and we could not have accurate observations. All right, in conclusion, charge is powerful, especially at low distances, and that different methods can be used to charge electrons and charged objects by adding or removing electrons, and the charge will discharge over time and the objects will become inert. Thank you.